All right, welcome and good morning, everyone, and welcome to today's webinar, presentation, Migrating from Matlab to Python. Thank you for taking the time out of your busy day and joining us. We hope you find the presentation informative. I'm Kendra, and I'm the Marketing Communications Manager here at ActiveState, and I will be the moderator for today's webinar. There will be time at the end of the presentation for questions, and if we don't have a chance to answer yours, somebody will follow up with you after the presentation. And we'll also be archiving this presentation on our site, so you can get it on demand afterwards. Before I get started, I just wanted to do a quick poll to get an idea of who our audience is today. The poll will show up momentarily in your dashboard, and just please pick one of the following choices. I'm just going to launch the poll right now. All right, so question is, what is your primary reason for attending this webinar? You're currently using Matlab and plan on migrating to Python soon. You are a Python programmer interested in anything Python related. You're a fan of Matlab and interested in this topic, or you're a quant financial engineer and interested in learning and using Python, or none of the above. So I'll just give you a few more seconds here to make sure everybody has a chance to make a pick, and the results are coming in. All right, so basically the majority of you seem to be Python programmers interested in anything Python related. So that's great. Now we're going to get back to our presentation. So First, I'd like to introduce Diane Müller. She is our Director of Enterprise Product Management here at ActiveState, where she is responsible for managing dynamic language solutions for the enterprise. She has been designing and implementing products and applications embedded into mission-critical financial and accounting systems at Fortune 500 corporations for over 20 years. With her passion for open standards in financial services, she has been actively involved in development efforts for XBRL for the past 11 years and serves on the XBRL International Steering Committee. And we also have Dr. Mike Müller today, who is the CEO of Python Academy in Leipzig, Germany, specializing in Python teaching and consulting since 2004. He's an engineer who also works in research projects and uses numerous scientific Python packages on a daily basis and teaches a course on Python for scientists and engineers. He's a member of the Python Software Foundation, chairman of the PyCon DE Conference 2011, and runs a Python user group, and is generally passionate about developing in the Python community. And so with that, I am now going to pass it over to Diane.
So a little bit about today. First, hello and welcome to this webinar on migrating from Matlab to Python. It's a pleasure to be here today with Dr. Mike Müller of the Python Academy. And we're going to talk today about the basic building blocks you need to know about Python in order to create your own Matlab-like environments to work with your financial or scientific or research data. And we're going to talk a little bit first about what ActiveState is and what the Python Academy is. I'm going to do a quick comparison between Matlab and Python. And then we're going to have Mike do a deep dive into Python's what we call Pylab functionality, including the basics of Python, NumPy, SciPy, IPython. And we'll talk about some other considerations and have some time at the end for Q&A. So a little bit about ActiveState. ActiveState is the world leader in enabling companies to develop and manage and distribute applications with dynamic languages. Dynamic languages are in our products and services for Python, Perl, and Tcl, and other web languages are used by over 2 million developers and 97% of the Fortune 100. So I wouldn't be surprised if many of you are already using our language distributions to build and run applications from everything from mission critical to open source projects. We have development tools called an IDE called Komodo, and a lot of other OEM solutions that we have in-house. And our language expertise includes a strong knowledge of Ruby, PHP, and JavaScript, which are also supported in the Komodo IDE and Komodo Edit, which you may be familiar with as well. Next slide. So a little bit about the Python Academy. They're specialists in Python training. They have open and they do develop custom courses for organizations. They really are have two threads, Python for programmers and then Python for scientists and engineers. There's lots of custom advanced topics that they talk about, and they do a lot of wonderful Python consulting, so we're very happy to have them here today. So as I said, our tools cover the development tools and our language distributions, Active Perl, Active Python, Active Tickle, the Komodo IDE. There is also Komodo Edit, an open source editor for these languages, and we have our dev kits. So really, we take those and we springboard into being able to create enterprise solutions for of the language distributions that have some support, management, and compliance pieces to them, including some indemnification. We do training here as well, and we provide a lot of commercial support. So, and then for people who are distributing Python and want to have a packaged OEM solution, we have tools for that as well. So in our Active Python Business Edition, everything that you're going to learn about today for building your own MATLAB or creating a Pylab, including NumPy, SciPy, and matplotlib, which you'll hear Mike talk a lot about today, are included in the Business Edition distributions of Active Python. We also include the GUI toolkits that you need to build desktop applications, PyQt, WXPython, and a lot of database connectors. And there are a lot of other wonderful pieces in there too, and the other new addition recently is adding in the M2 crypto package as well for those of you that want to do secure data encryption, because we know some of the data that you're working with is quite sensitive data. So just a quick comparison here between MATLAB and Python. So today, MATLAB has been around for many years. It's a proprietary environment, really, for working with financial data and scientific data, and is used by many folks in engineering and research. We're not here to say we're going to replace every functionality that is in MATLAB. There's years of work has gone into that. MATLAB, though, is proprietary to MathWorks. It includes its own high-level language, and it has a wonderful interactive environment with deep computational libraries that allows you to do visualizations, and they have a wonderful workbench. And there's a lot of good work and great training that goes on there. However, for those of you who are Python developers and have worked in the open source world, it has a much higher price tag than what it is if you roll your own, as we say, and build your own Pylab, and you're able to run the scenarios and do the research that you want. Python in and of itself is a high-level language. It's a dynamic scripting language. It comes with all of the packages that are freely available for the most part that you need to build your own Pylab. Custom graphical user interfaces. It has the libraries for all the mathematical functions, linear algebra, statistics, Fourier analysis, filtering, optimization, numerical integration. You can do 2D and 3D graphics functions, and you'll see a little bit about that today too. All the tools you need for building custom graphical user interfaces, interactive, and creating interactive tools for iterative exploration and design and problem solving. It easily integrates into external applications and languages. We wrap a lot of C libraries and a lot of additional libraries with Python and distribute them through the open source community. As well, multiple development environments are available for working with Python and building these. So it's a much more open and flexible language that can do just about everything that the MATLAB product can do, but you are again rolling your own, but building on the backs of giants, because there are very many wonderful projects out there, from NumPy to SciPy to the R libraries to, as I mentioned, the GUI toolkits that you have that are all pieces of the puzzle to put them together. And that's today what Mike Mueller is about to talk about, and he is not a brother of mine, that there must be a distant connection. So without further ado, I'd like to hand it over to Dr. Mike Mueller from Leipzig and the Python Academy.
Thank you, Diane. Hello, this is Mike speaking from Germany. Hello, everybody. Next slide, please. I would like to talk a little bit about Python itself first. So for those of you who don't know much about Python, Python has been around for about 20 years. It's been originally developed by Guido van Rossum. He's a Dutch guy, but living in the States for quite a while now. And actually his first intention was to have something, C is to low-level language, and shell scripting is not very powerful enough, and Python should fill the gap. And he was involved in language design for many years. So he has a lot of ideas from ABC, which is a teaching language, C, Smalltalk, Java, Pascal, and other languages. And he came up with this language in the early 90s. And I myself started in 1999 with Python, and ever since I'm using it. And now we are 2.7 and 3.1. And there's also Python Software Foundation, who is a owner of the intellectual property of Python. Next slide, please. Okay, Python's open source, has a special license for programming languages, allows you to do pretty much everything you would like to do with the language, including selling it. So it's a very, very open and liberal license. I mentioned the Python Software Foundations, and there are core developers that develop Pythons themselves, and there are a lot of other developers that develop many, many of thousand packages and libraries in Python you can install and extend the functionality of Python. And there's a process where there's called some Python enhancement proposal to get those things in. Next slide, please. Okay, a few features of Python. The first thing, it's rather simple compared to other object-oriented languages. It strives to be very consistent, which is a big feature, so a lot of things are very consistent. And readability is a very big thing in Python, though you want to write very readable code. It's a general purpose language, so unlike Matlab, it's not specialized in one field, but still it can be used for a lot of specialized purposes. And you can do a lot of introspection in Python, so you can research a lot and implement in the same language. That's very interesting. And yet, even though it's a general purpose language, it makes up a pretty good replacement for Matlab if you combine Python itself and then this package, as we mentioned already, NumPy, matplotlib, IPython, and SciPy, among some others. But you can do other things you cannot do with Matlab. We can have another look at this. Next slide. Okay, a few users. Who uses Python? The user community is very wide. A lot of open source projects built on Python. Google uses Python. YouTube is written, there's a quite big part of YouTube is written in Python. The German Aerospace Center is a very big German research organization. It's using Python heavily, like NASA. Walt Disney using Python producing his movies. Rackspace for hosting, but also in the financial sector, Python is used quite a bit, and there are many, many more users. Next, please. Okay, besides organizations, there are also different types of users. So Python is very well suitable for programming newbies. So if you haven't programmed before, Python can offer a very gentle introduction to programming. But at the same time, it offers enough for professional programmers to develop really sophisticated professional programs. So the learning curve is pretty gentle. So you can start with just a little, but you have a lot of room to improve later on. Python is very strong in testing because it's easy enough for testers to use Python to set up testing systems. Sysadmins use Python a lot, though it's more powerful than shell scripting, but still not as much work as using a compiled language, for instance. And scientists and engineers, I'm involved with scientists and engineers quite a bit, and quants, which I count in this group. And they use it a lot because usually programming is not their main part. They just use programming to solve some of their problems, and though Python is a very good match for them. So I would say Python scales, so it's pretty easy to get started with, but you have many advanced features if you need them, and you can do a lot of things later on. Next slide, please. You see, that's one of those graphs I made from what's called the Diobe index. It's just one way to determine the popularity of programming languages. You can have different opinions about it, but you can see here this green slice there, it's Python, and it's number 7, just right after C#. So Python is used quite a bit, and it's pretty popular. Not as popular as Java, though, but pretty popular. So you can see it's not a French language, it's a popular language. So again, it's easy to get started with. For instance, MIT is using Python in their introductory courses for computer science and programming. Michigan State replaced the first semester C++ courses successfully with Python. And it's embedded in a lot of products like Blender, OpenOffice, Inkscape, or GIMP. And a lot of people say programming Python is fun, which is important for a lot of people. Next slide, please. So it works on a lot of different operating systems, all the major ones, Linux, Windows, Mac, but also on mainframes, mobile operating systems, and even old DOS systems if you still have to work with them. Next slide. So a few words about technology. If you don't know, it's interpreted. So everything is interpreted, it's compiled to bytecode, very similar to Java. It's platform-independent bytecode, so you can move it around, independent of the operating system. And pretty much everything happens at runtime, which is a big, makes Python very dynamic, and a lot of things get much simpler, a lot of dynamic things, and makes metaprogramming much simpler if everything's dynamic. Next slide. There are a few implementations. So far, when we talk about Python, we talk about CPython, which is a standard Python written in C. But there are a few other implementations which are compatible, so they have the same syntax, it's the same program, but a different underlying infrastructure. It's called JSON, which is implemented in Java. There's an IronPython, which is implemented in C# running on a .NET framework. There's SciPy, which is Python implemented in itself, which is a very interesting project now that they're just getting from the research stage to slowly the production stage. And there are Stackless, which is a different kind of implementation of CPython that allows very, very many actors or parallel processes in Python. Okay, a few features. So I just start with some examples. Let's say we have a file, it's just a simple text file with 3 columns, with columns A, B, C, and have a few numbers. And there's a very simple way to read this file. Next slide. So if you read this file, then this is what's called the interactive prompt. You can work at the interactive prompt. And I just open this file with the open command. And then this file is what's called an iterator, and I just can say next. This next locates the next line, and I split this line. You see, I split this line in ABC. And now it goes through all the rest of the file with the lines and goes through all of them. And I do quite a few things in one line. I just have this numbers, which is an empty list, and I append for every line I append another list, which is this square brackets, and I convert every entry in this line, which I split, add white space into an integer. So that's what I do in this one line. And at the end, you see numbers now have the whole file in one list. So it's a very simple way to do file input, for instance. Next slide, please. Okay, so that's very simple, but we can do a lot more with Python. So there's called a CSV module that gives you much more features if you want to read comma-separated files. There are very nice libraries for reading and writing Excel files, XLRD and XLWT. But you can also, if you work on Windows, you can use COM and can use all the functionality of Microsoft Office instance, for instance, if you need to access Excel or other files. You can read and write HDF5 files, which are, it's a very nice, HDF5 is a format for a large amount of data. So you're talking about terabytes here. And this is a binary format, very fast. And there's a very nice interface in Python, PyTables, that allows you to read and write these files. You can access NetCDF files, yet another format for binary data. There are some opportunities to do this in Python. You can read binary files, which are actually pretty fast from Python, with a struct module from the standard library. And there's many more ways, many more libraries for Python. If you just Google for Python and this desired format, you will find a lot of different libraries. Next slide, please. Okay, you can also connect to databases. Actually, to all major databases, I think there's a connector to all of them, and you have something that's called an API in Python, so you can use the same API from Python, no matter what database, as long as you're doing anything very special to one database. You can change your database without changing your code. So Oracle and SQL Server, MySQL, Postgres, DB2, SQLite, and a lot of many more of databases. Next slide, please. Okay, there are also what's called object-oriented mappers. So if you don't want to work with SQL itself, you can work in Python, and this is translated to SQL in the background, which is most of the time more performant than writing the SQL yourself. And there's one very interesting library called SQL Alchemy, which is very powerful in doing this. There's another one, simple one, SQL Object. And you can use object-oriented programming, don't have to write any SQL by hand, and there's no way to do SQL injection in your code if you do this. Next slide, please. Okay, now let's come to NumPy. So NumPy is the package for working with numeric arrays in Python. It's been around for quite many years. It used to be called numeric before, now it's NumPy. And it has a lot of Matlab-like features, but you can use those features from Python. Itself, it's implemented in C, though it's pretty fast because everything runs in compiled code, actually, the numerics, but you can still use Python interactively. And unlike Python, which has very limited data types, it has 21 data types because it's a very different kind of way of programming than pure Python. Next slide, please. So let's look at some examples how to work with NumPy. So this, again, is an interactive prompt. And first, we have to import NumPy. And it's convenient to just shorten the name to NP. So we import NumPy as NP. And then we construct an array. We create an array just by saying np.array. And then we provide the data. So this will be a two-dimensional array with the numbers 1 to 6. So if you look at it, it's an array, two-dimensional, and then you have a shape. So it might look familiar. You have a shape, and it's 2 by 3. So you have 2 dimensions, and you have 3 integers in the first dimension. That's a 2 by 3 array. And it has a data type. It's an int32, which is the default integer of Python. And you can see the size is 6, so it has 6 elements inside. So that's a very simple way to create arrays. Next slide, please. And there are a few other ways. There's one command called arange, which is very similar to the range in Python itself. So with arange, as you can see here, I create an array of the integers from 0 to 9. So it's always in Python, the first one is inclusive, and the last one is exclusive, starting with counting at 0, as you usually do in Python from C. And you can see now, this would be a one-dimensional array, but you can also, if you construct the array, if you say C is equals NP array, construct the array, and you can define the data type. So you have the ability to define the data type, and unlike Python, where every object, you can reuse a name, here now you decide for one data type, and all the elements of this array have to have the same data type. And you look at them, it tells you the data type, it's not integers anymore, it's floats. Next slide, please. There are more ways to do this. So very often it's very convenient to use arange to create a one-dimensional array, in this case 16 float numbers, one-dimensional. And then I use reshape, and I say reshape 4 by 4, and I create a two-dimensional array, a 4 by 4 array, you can see. So of course you have to use 16 if you want to reshape by 4 by 4, it has to match. So you can reshape this array. That's a very nice feature if you want to construct arrays. And there are a few special commands. One is zeros. So with zeros, I get a 3 by 4 array with all zeros. If you want to initialize some array with zeros, just say zeros. Next slide, please. And similarly, there's a ones. So you just, if you like, have the array with ones, you just say the same thing once, and you get an array with ones. And also, if you like to initialize an array with 5s, then you just say, I want to have an array with zeros, and then I just add 5, and I have an array with 5. So that's a very fast way to construct some arrays. Next slide, please. Okay, data types. So unlike Python, which has a very limited number of data types, NumPy has lots of data types, and you can see most of them correspond to C data types. So for instance, for integers, you have signed and unsigned versions of 8, 16, 32, and 64-bit integers. So that's 8 of them already. You have floats. So you have 32, 64, and 96-bit floats. And you have complex numbers also in different kind of sizes. In addition, you can store Boolean values, strings, characters, and even objects if you like to. And if you count all of them, in the end, you will have 21 data types. So it's a lot. It's very different than normal Python, where you have just a very limited number of data types, which is intentionally. So you have way more options here. So if you want to save space in storing data, you can use smaller data types, for instance. Next slide, please. Okay, let's look at the data types. So now I create an array again with just 3 numbers, 1, 2, 3, and I say I would like to have the data type int64. and now I have int64. And this data type has a few properties. So if you say a data type, I can see it's int64. But also there's a data type which gives you the type from Python kind of view. So it's a NumPy int64, a special data type. And also there's a character char involved, which you can use. And there's also str that tells you it's this less sign means it's a little endian integer with 8 byte. So 64-bit is 8 byte. Next slide, please. Okay, one of those very interesting features of NumPy is the slicing. So how to access your array members. Usually you could write loops, but NumPy offers a lot of opportunities to access your data without loops. So this loopless programming is a big thing. So let's look at an example. I create a one-dimensional array with 10 integers here, 1D. And now I can access it very similar to Python lists. So just you start indexing with 0. So if I say 1D 0, I get the first element. 1D 1 gives me the second one. And with minus 1, I start from the end and I start indexing from the back. And I can also slice. So I say 1D 2 colon 5 gives me all the numbers starting, including from index 2. So we start at 0, so with 2, up, but excluding 5. So very similar to Python lists. So you can access those one-dimensional arrays. Next slide, please. Okay, this is very similar to a list, but as soon as you go into more than one dimension, then things get different than Python lists. Now I created a array with 25 elements with a shape of 5 by 5, as you can see here, 2D. And now we can access it also with indexing. And if I say 2D 0, 0, I access this 0. So the first line, first column, this 0. So the first index is a line, the second one is a column. And if I say 2D 0, I get the first line. As you can see, the numbers between 0 and 4 is the first line. And though I can access my array this way. Next slides, please. Next slide. Hello? Can I have the next slide?
Yeah. Oh, it's gone. It's just having a delay, I think. Just
okay,
one moment. Is it on? Is it the right one now, Mike?
Yes, I think it's still the old one.
Little tiny bit to go.
One more ahead?
Do you see it?
Oh, it's just delayed. Sorry, it's the software. How about now?
Okay, no problem.
Perfect.
No problem. It's still, now it is. Okay,
great.
Now can you go back one, please? This was one too many. And we look at slicing again.
Back
one. Back. No, another one back. Okay, that's perfect. Thanks.
Okay.
So slicing again. So if you look at this slice, so you can, if you like to, also slice column-wise. So if I use this column there before the comma, that means takes the first full dimension and then the zeros column, the zeros element of the second dimension, which gives you the column. And the next one means give me everything from the first dimension starting from 1 up but excluding the last one, and then from the same thing from the second dimension. So 1 column minus 1 and 1 column minus 1 gives you like the core of this 5 by 5 array. So you cut off the first and last row and the first and the last column, you only the inner ones. So this is one way of slicing. And you can get pretty fancy. This is what's called simple slicing. And there's something called advanced selection, which you can get even fancier and can do fancier things. So we don't have time to go into there, but you can do a lot of slicing. And the main thing is you don't need to write loops anymore. For a lot of problems, you don't need to write loops. And if you don't write loops, you don't actually work in Python. You push everything to NumPy, and all this code is executed in C, which is much faster. And also, if you don't write loops, then it has the potential to be parallelized. You can run it in parallel potentially because you don't have any dependencies during the loop steps. So if you don't use loops, everything you want to write in parallel, usually you want to avoid loops if possible, because loops are more difficult to parallelize than doing this loopless programming. Okay, that's slicing. Next slide, please. Okay, broadcasting, it's another thing which is important in NumPy. So we have our two-dimensional array again, and now I can just add 5 to this array, and it will be added element-wise. So every element will be incremented by 5. And this 5 is broadcasted, so actually if you can imagine this 5 is used 25 times broadcasted, and then use the same 5 for every element. Next slide, please. So you can also do this broadcasting with not only with scalars like the 5, but also with arrays with different dimensions. So again, we create an array with 8 elements and reshape it 2 by 4. It looks like this A here. And then we have another array, it's B, which just has 4 elements. And now we can add both of them, A plus B. And the result is now this B is used twice. So B is added to the first row and added to the second row. If you look at it, if you look at the 10 there, the 10 is a result of 7 plus 3. So it's the very last number in the result, the 10. It's a result of the 7 from array A and the 3 from array B. We just add them together because this array is broadcasted, so array B is used twice here. One for the first row, and one for the second row. So that's what's behind broadcasting. And there are more rules, but that's one of the basic rules for broadcasting here. Next slide, please. And there's one more thing I would like to mention about NumPy, which is called universal functions. Universal functions are mainly functions in NumPy that can be applied to a whole array. See, I use a sign function here, and I just say A, and this is doing element-wise sign for every element in this array. So you don't have to write a loop and apply it by hand. This is done in the background again. So again, no loops. We push back the loops to NumPy and avoid writing our own loops. So there's like 60 to 70 of those universal functions in NumPy that help you to do all this. And they have some properties like n-in, so the number of input arguments, the number of output arguments, which are 1 here in this case, and also the types. You see the types. So this gives you this letter which I showed before, and it shows you can use floats and doubles and whatever kind of types that will get in, and the same type will get out. So all of those universal functions have this information, so you can see how they work. Next slide, please. Okay, so far we talked about arrays. Arrays are multi-dimensional. There's no limit on dimensions. You can use 1 to n dimensions. If you like to, you can use 10-dimensional arrays. There's second type of object in Python, in NumPy. Those are matrices. They are different to a certain degree from arrays. Of course, you do matrix operations. Just a short example here. You have this np.matrix, which gives you a matrix, and you can see how you can use it. If you like to, you can use the same syntax as for arrays, but you can use this simpler syntax, just a string with a semicolon. Might look familiar. And with this one, you can create a matrix. And this matrix, they are always 2D. Whatever you do, you can always have 2-dimensional matrices. And then they have a lot of properties, like the capitalized I gives you the inverse, and then you can just turn A to inverse. And you can do matrix multiplications and things like this. So you can work with matrices. So they are much closer to Matlab matrices, where arrays are more general purpose for work with multidimensional objects, but you can always convert back and forth between both. So if you have a 2-dimensional array, that's just say matrix, and you just give the array, then it converts it back and forth, and all matrices have a few as in an array. Next slide, please. Okay, this is NumPy. NumPy is a very basic package. That's why I dwelled a little bit more on it. So it's very important because pretty much many other scientific packages, they build on NumPy, including SciPy. So SciPy and NumPy are interconnected, and actually they have some overlap. And SciPy is a very big package, and it assembles a lot of different functionality inside, and has like 800 pages documentation. There are still quite a few places there. There's not so much. It's a pretty big package, and a few areas it covers is interpolation. It has some linear algebra, fast Fourier transformation. You can do statistics, some optimization, and many more. So I don't actually go into detail here. I just tell you there's a lot of things in SciPy. It depends what you're doing. you probably will find some package in SciPy, and everything in SciPy actually is written in C and Fortran, so there are fast, reliable numerical algorithms in there, and they are just collected and accessible from Python. Next slide, please. A very nice thing is IPython. So IPython, it's not a special tool for the scientific user, but it's very useful for the scientific user. It's actually an improved interactive shell and gives you a lot more power than the standard Python interactive mode. And you can do a lot of object introspection. You can just call shell commands, like you can list a directory and things like this just directly from there. And you can also, it's extendable. You can add your own commands. And you can use, if you use IPython minus Pylab, you get a very nice interactive prompt for Matlab, matplotlib. We're going to look in a minute at matplotlib. So you can do interactive works with graphics. So you can do something and graphics are changing online. Next slide, please. Okay. Next thing is matplotlib. So actually we use IPython here only as an example for using matplotlib. So this is just, I started now IPython minus Pylab, which imports matplotlib. And the very simplest plot you can do is just say plot random 100. So this random is a random from NumPy, which is imported, and I just create 100 random numbers between 0 and 1, and then I plot them. And this is a result below. You can see this graphs. So it's not very fancy, but it can be useful. So this is only one line, and you get this graph. And now you can go on. You see there says in and out 1, which is a feature of IPython, and you can go on and change things, add things, change colors, add titles, and things like this, and everything will be updated interactively, which is a very nice environment. Next slide, please. So you can do a lot of things with IPython. You can recreate very nice publication-ready graphs. So you can add colors to all those properties. You can add line styles. You can add markers. You can add legends. Let's have an example. Next slide, please. So, what I'm doing now here, I just work in the interactive prompt in matplotlib, in IPython, and I just create an array of the numbers 0 to 99, which is x, and call it linear. And then I create the numbers between 0 and 10 with a step size of 0.1 and square them, which is my squared. And I use both of those numbers, those arrays, and create a plot. Says lines is plot, and I use x for the x-axis in my linear. This will be my first line. And then I provide a very short string for the properties. It's a green dotted line with pluses as markers. And the second line in the graph will be also has an x-axis, and then with my square numbers, and is red dashed, and there has circles as markers. And then I even add a legend, which is just says linear and square, and I put the legend at the upper left corner. Next slide, please. And this will be the result. So you can see the result. So you have the legend up there, and you have your two graphs, the red one, which is the squares with the circles, and then the green one with the crosses, there with the pluses. So in this way you can keep going and add more things interactively. So that's a very simple way. So you can make very simple graphs, but you can also do more sophisticated graphs. Next slide, please. So just a few examples. So this is ticks and formatters. Very often you have a lot of, you need to format ticks. You see down there is a nice formatted x-axis, and I do this with the concept of locators and formatters. There's a locator, and I say I would like to have a different kind of locators for the ticks, and I would like to have a multiple locator, so every 10, every value of 10, I would like to have a markers here, 0, 10, 20, 30, and I provide a formatter. I want to have a floating number, 5 long with 2 decimals. And also I can specify I would like the multiple locator every 5. And then I just set them. So I set a property that's a major and minor locator on the major formatter, and then I redraw my graph and I see the result. Next slide, please. Okay, just a few examples of nice plots. So these are plots just from the Matplotlib gallery. So you can see here you can do pretty sophisticated plots with a lot of things, so you're pretty free. What you like to do, you can adjust things in those plots, and you can also save those plots in many different vector and pixel formats. Next slide. So there are many different kind of coordinate systems. You can do this kind of type of plots. There are many more. There are hundreds of different kind of plots, and lots of them look pretty fancy. Next slide, please. So even more. So very different kind of plots you can do besides those normal time series plots. Okay, so that's just a very quick overview about those things. Python and Pylab, Python with NumPy, SciPy, and IPython, and matplotlib, it's pretty close to Matlab, but it's not no full replacement. You can do a lot of things, but it's not a full replacement, so there's no Simulink. Especially in SciPy, there are some missing documentation, and for some toolboxes you don't have equivalent libraries. It's a smaller user base, and you have this distinction between arrays and matrices. Arrays and matrix. Next slide, please. So some functionality in SciPy and NumPy is duplicated, and sometimes it's difficult to find the right library that's emitted, and the IDE is not as polished. There might be a few kinks here and there. It's not as polished yet as Matlab. Next slide, please. Okay, but there are some advantages. So Python is not an island. So if you like to reach out to other systems, Python can do this very easily. You can extend Python with C and C++. You can work with JSON, with Java, with C# with .NET. There are Swig, Zip, and Boost to wrap C and C++ libraries automatically. You can work with .NET, with COM. There's Cython. I will talk about it in a second. You can embed Python in other programs, and you can access even compiled DLLs or shared libraries, which is very nice. Next slide. So one example is Cython, and Cython allows you to call C and C++. Just a very simple example. So Cython looks very much like Python, but you have a few extensions in terms of syntax, and you can just say cdef extern, and you see I just define this function with a very similar Python-like syntax, but it will be eventually compiled to C, and I can also use this sign here, which is part of the math library and from C, and this helps you can use this C function to do your computations, for instance, but you can also define your own functions, the C double here, and you define the double, so you have a data type. So this is very different. This will be compiled to native C code and will be probably faster because you can really use the C double to calculate instead of Python double, which is much slower. And the nice thing, it works also with C++, and there's a lot of momentum, a lot of people doing work with Cython now, and there's a lot of things going on, and it's a very nice library. Next slide, please. Okay. Okay, one big thing of Python is called the glue language. So it can be used to connect systems of heterogeneous elements. Like you can generate easily input files for something, start and control processes very easily, and read output files. So start external processes very simple. You can communicate over the network, you can do a lot of things, and usually it's fast and just need to write a few lines of code doing this. Next slide, please. Okay, Python's interpreted language, Python itself is not that fast for numerical. For a lot of things, for string processing, which is pretty fast, for numerical processing, it's not that fast. But we have NumPy, which is in C is very fast, but there's a lot of things that are developing now. There's a lot of movement doing multi-core processing. There's multi-processing in the standard library that gives you access to several cores. There's a lot of work going on with GPU processing. There's Slicer and PyCUDA, which help you to write code for CPUs. And there's one rather new library called Diane that actually you can write pretty much NumPy code, and in the background it will be translated to C or to CUDA or OpenCL code that can write on GPUs, and it run on CPUs, it makes things faster. And this is very nice because you have the same NumPy interface, because programming GPUs is not that simple, and it helps you take away a lot of the burden. So there's a lot of promising development in this area. Next slide, please. And there are way more scientific libraries to use. There's a bridge to R, so if you use R, you can use it from Python. So everything you know about R, you can apply, you can use it from Python. There's a scikits, it's a time series and other tools, the extension to SciPy. Pandas is a very nice time series and statistical analysis used in quantitative finance quite a bit. There's Sage, which runs in the browser, and they strive to be alternative to Magma, Maple, Mathematica, and Matlab. So they use a lot of those things I showed here, NumPy, matplotlib, but connected in one package. And if you go to the PyPI, which is a Python package index, and that has about 760 packages that are tagged with science and engineering. So there's quite a lot of things to explore there. Next slide, please. So what else? So that's not really all. Since Python is a general programming language, it has a very strong standard library. It's called batteries included. You can do a lot of things with the standard library. The Python package index I mentioned has more than 12,000 packages with lots of different software. You have wrapper for all major toolkits like WXPython, PyQt, TK-Inter. There's plenty of web frameworks, Django being maybe the most known one, SOAP, but also TurboGears and Pylons. I mentioned you can access all major databases, and usually if you need some library for some purpose, if you just search for something, you will find a library. Most of the time you will find something that solves most of the problem. I'm pretty sure because there's so many things out there that you will find something. Next slide, please. Okay. Thank you very much.
Great. Thanks, Mike. That was great. And we've ended at a perfect amount of time for some questions from the audience. And I'm going to give everybody a few minutes. We've already got a couple coming in. The first one from Doug is, does Matplotlib support the step plot like Matlab? And I don't know if Diane or Mike want to take this one.
So Mike, I think I'll start this and maybe you can finish it. Matplotlib has a subfunction called pyplot, which if you go onto the Matplotlib API site at matplotlib.sourceforge.net, you can read all about that, and it does indeed allow you to do step plots. Mike, do you want to add anything to that?
Yeah, I haven't used it myself, but it has lots of functionality and has a very good documentation. So the easiest thing is just go to the nicest thing if you want a visual approach, go to the Matplotlib site, and they have a gallery with hundreds and hundreds of different example graphs, including source code. So it's very nice. Just look at the graphs, and then you can download the source code, and you have a running example file you can work with, and it has plenty of features.
Great. Thanks, Mike. Next question is, where can I get these Python modules?
Now, as Mike mentioned in here, the source for these can be found on their on PyPy, which is PYPI at thepython.org. Or if you're looking for the binaries and the pre-built distributions of them, you can find them and all the information about them at www.activestate.com/ActivePython, or you can go directly to what we call our package manager index, which is at code.activestate.com/pypm. So you'll be looking for the Python package manager index.
Thanks, Diane. I've got another question from David. In your experience, is Matplotlib the predominant Python plotting library, and are there others?
It's a predominant one because it allows a lot of simple ones. There are certainly other ones you can use if you like. You can access GNU-plot from Python if you're familiar with this. There are a few other more interactive libraries, more sophisticated libraries from Python, but Matplotlib by far is the biggest one as far as I know. So most people use Matplotlib because also in the last few years it developed quite a bit, and you can do a lot of things. I do animations with Matplotlib, very nice ones. So and then it can be pretty sophisticated.
Great, thanks, Mike. Just a quick note, a couple people have asked, yes, these slides are going to be available after this presentation, both the on-demand version of the webinar, and we'll post the slides to SlideShare, our account there, so I'll send that information out to everybody. Okay, we've got another question here. What the difference is, what do you get in Business Edition versus Community Edition of Python? I guess you mean ActivePython.
So I'll take that one, Mike. So the ActivePython Business Edition versus the PyPy out there in the universe is delivering the source code, so you have to build your own binaries. So that's with ActivePython, we do all the builds for you across multiple platforms, Windows, Linux, Mac, come in for the CE, which we call CE is our Community Edition, which is the free edition. But in the Business Edition, you also get a variety of Python packages or Python modules, including the ones that we mentioned today, that some of the database ones, the crypto ones, the GUI toolkit, and then you get builds of Matplotlib, SciPy, and NumPy, and we're always adding more in there. There are additional operating systems available, so if you're looking for other ones or earlier versions of Python, you can give us a call. But really what the Business Edition is all about is giving you the binaries along with the support and the technical backup and the QA on those binaries, so it saves you the time, because some of these modules themselves are a little difficult to build and require additional libraries and hand-holding and certain patches on different platforms, and so that's what we do for you in our Business Edition distributions.
Thanks, Diane. We've got another question here. What is the current state of parallel programming in Python? I've heard something about the GIL, which apparently some people think makes Python not well suited for parallel programming. Mike, do you want to take that one?
Yeah. Okay, that's a big topic. So, and actually, Python is not going. Python has a GIL, so you cannot run. So if you run threads in Python, they will only use one core. That's right. But Python has now, since 2.6, included in the standard library a package called multiprocessing, and this actually goes a different route. So instead of using threads, you use several processes and you communicate between processes. This has the advantage that you can pretty much avoid all those deadlock conditions, those race conditions, because you just communicate with queues between different processes, and then you can still use more than one core on one machine. That's one way to do it, but there are also other libraries. So if you, I used to use one like 8 years ago, working on a Linux cluster, and it worked very nicely. And I just, because the Linux cluster, you have to use different processes anyway, because you have different machines. And there are some, I used one called Python Remote Objects, which I like most of all of them. And it's very nice. You can run it on the cluster, and I had a very nice speed up for my problem. So there are some solutions. And there are some kind of philosophical opinions if you should use threads or not. But if you use threads, you might get some additional problems in terms of locking and things like this. So I think I like this approach with processes. And I think for scientific and numerical computing, which is long-running and CPU intensive, that's a very nice route to go.
So one of the other attendees also pointed out, and I'll just add in this, that there are NumPy releases, that NumPy releases the GIL for many operations, as well as there are some methods passing interfaces such as MPI packages, a package called PyPar that'll help out with parallel processing, and you could do a search on that or on the project called OpenMPI, which will give you some more background into these issues too. But it is, as Mike insinuated, a topic for another webinar, I'm sure.
Okay, great questions. Thank you to everyone who asked one. And if you have a question that you didn't have a chance to ask or are curious about, please contact us at any time. There's You can webinars at activestate.com, or either Diane or Mike, their emails were on the first screen. And so that's all the time we have today. And thanks again for spending your morning or afternoon or evening with us. Check back to our site regularly. We have webinars. We'll be announcing a new schedule for 2011. And that's all. Thank you to Mike for our co-presenter from Germany. And we will hopefully see you all, or present to you all again soon. Thanks.
Thank you. Goodbye.
Thank you, Mike.
Thank you, Diane.